Okay, it looks like we are live. So welcome back. Today I'm going to be continuing to work on my virtual machine. Okay, so right now, I think what I want to do is add registers. So that, I'm not sure where I'm going to go with it. So I'm just going to kind of implement them and see where it goes. And I might not actually use them at all. I just kind of want to see how they work. Yeah, so I've added a new to-do list, add registers. So I think we can start in pim.h. Whoops. Okay, so we have in the definition of the machine, let's see if I can find it. I think we need to add a register. So let's add struct, type def struct, and this will just be called a register. And I think I will capitalize this. All right, register. So the register, it's just going to contain a word of the data, essentially, is what it is. Yeah, and so I don't know that there's going to be much else in it. So we will have a register, and then we can have basically all the registers will be in here. So I'm thinking, should they be an array, like an array of registers? And then basically the index would be the register number, essentially. So then, that might be a good idea. Let me define registers, and we'll just do 4 for now. Yeah, so then I'm just gonna try things out. So I'm not sure how I'm gonna end up doing this, but yeah. So let me put right here register, and then registers, and then the size will be registers. Maybe amount of registers. Yeah, so I will rename this to amount of registers. Okay. So that will be an array of registers, and then the index will be essentially the number. I think that could work. So we're going to need a new instruction for these as well. To move data into them, we will need an inst move. So I think that could, we do have move stir, so let me put it right before that. So inst move. Oops, inst move. Just like that. So in the cannot.c, right here, we'll do case inst move. And for now, it will be assert false, because it's not implemented yet. So now we need to implement this on the level of the virtual machine. So what I'm thinking, let me make a test.tasm file and open that up. So we could push 5 or whatever, or we could move R1. So that is the register and the index. So starts at 0. So 0 and 1 are the ones that you use. Yeah, but basically, I'll sort of get into that after. So it could be 0, 0, 1, 2, or 3 right now, because we only have 4. So move R0, and then just whatever value you want to move. So it could be that or that. So it's basically like push, except for registers. So, yeah, I think that's what we'll do. So we need a way to define these registers in the TASM lexer. So in here, so we do need type move. So that's the instruction that we added. And then we also need another one for type of register. So type register. So I think down here, that can go after all of these. We can have type register. So maybe, should the type, so basically if it, let's see. So if it is not a keyword, we'll check if it starts with R. And if it does, then it's a register. Actually, maybe that's not. Maybe we'll have type R0, like basically a different one for each register. Yeah, so I can just do something like that. There we go. So 1, 2, and 3. So that's what we have right now: 0, 1, 2, and 3. And then in the lexer.c, we need to add those things. So after where is move? Move stir right here. We need to add move, just move. Yeah, and then we need to add So I suppose count. Yeah. So let's see. Did I put it right after null? Yep. So R0. Yep. And then 1. Okay. So I think that should be good. So R3, R2. Whoops, and I messed that up. R1 and R0. Okay, so that should be good. Okay, so that's the registers, the names essentially. So what we need to do is actually check, um, yeah, check if it is a register. So check built-in keywords, right here. Yeah, so if it's one of these, then it thinks it's a built-in keyword. So we need to do that a different way. So we'll still have them in there, but basically we'll just let's define also the register. So registers, and this will be do we have register size, right? Are we including tim.h in here? I don't know. Okay, we don't. This is up here. Yeah, we don't include that anywhere. So yeah, so we'll need to standardize it, but for now I'll just do this. So it's full equals, and okay, so we have R0, R1, R2, and R3. Okay, so now we'll need to check if it's a register. So we want to do that actually before the check built-in keywords. So this is going to return a token type, yes. Actually, I'm thinking this isn't necessary because, yeah, because we return it based on here. So it's fine if it does that because it returns this type of keyword. So this is actually totally fine. Yeah, so we didn't need to do what I was just doing there. Yeah, so we have this. So that should get it in the lexer. And then we need to also define the move operation. So that's in the parser. So it works almost the same as let's see, what is the push? So rather similar to that. Yeah, so type, well actually it's not exactly the same way, so we need to do it differently. So basically, we can copy this, and then right here, we'll expect, just one, type, so it type move is what it is. Okay, so after that, we want to do index plus plus, and then, yeah, we'll set the current, we'll do a similar thing to this. Except we're going to be checking if it's a register type. So yeah, so we can just basically yes, we'll do this. Type R1, whoops, or actually R0 goes first, and then this is R1. There we go. This will be R3, and right here is R2, R2D2. All right. So yeah, expected register. That can be the error message. Expected a register. Okay, that should be fine. So then we check that. I think we need something like that in it. Okay, so now we're checking to make sure it's a register, and then right after that we want to get the actual data. So we do have to store this. We can do that right here. So if we append this to the list, and then we want to expect one of the registers. Or no, a value rather. So it's actually this same thing here, because it's going to be any of these values. So we can do this exact same thing. But we do have to actually index plus plus, and then set the next token. Okay, and then, yeah, we're expecting an int, a null, a character, or a float. Yeah, and so that is all fine. And then we'll just append that, and that should be it for the parser. Alright, and then in the Tesla.c, we need to basically do the same thing that we do with the push, except we have the register as well. So I need to think about how to do that, because we can set the operand value. Here, let me take a look at the implementation. So basically, in the instructions, yeah, we have a type, value, and then the data type. So so it would be a type of move. The value would be whatever the value is that we're trying to move. In the data type, okay, yeah. So the data type is just whatever the type of the data is. So we might need another thing in this instruction, which isn't used except for this one. So basically just a register. So yeah. So I think if we maybe define, well, let's see. So here we have register. So really we just need the index of the register. So the R0 would be the 0th index, obviously. So I think we can do something like index, size t register index, something like that. And then it's only going to be used with this one. So then, yeah, we can do a similar thing to this. Yeah. Basically, we'll go here. We don't want the push pointer though, because we are not actually, yeah, because that is for type null, so that is fine. But first, we need to get the register type. So we still do this. So we're going to do this twice, and then we'll do head value dot type. So we know that is going to be a register actually. So basically, just need to check. Yeah. So we need to check, and then so we need to index the array. Yeah. So what I can do is define an array here. Basically just an array of size t's. Registers equals, and then we'll have 0, 1, 2, and 3, basically. So then we want to set it to the index of that. So yeah, the way it's set up right now, it's kind of not easy to do that. So let me see. So right now, something we could do is just something like this, and then just do instruction register index equals 0, and then do the same thing for the rest of them. But I don't really like that implementation. I think I'll do that for now, and then I will make it better later. So let's just get something that works right now. Dot type equals R1. This could be a switch statement as well. Would that be better? Would that be better? Yeah, I'll make a switch statement. Actually, switch head value dot type, and then let's see, case R0. Then we'll do this, and we'll break. And then case R1. Yes, we can get rid of this, but we will use that later. So yeah, I'm gonna make this better. Okay, so R2 and then R3. And then, yep, whoops, I messed that up. It seems to be that. Okay, so we'll do that. And then default is just, we'll throw an error. So we'll actually assert because it shouldn't be false. And register should be one of those 4. There we go. So we'll do something like that. And then, yeah, we get the next one again. Okay, and that... Actually, no, we don't need to do that because we can just get rid of that. And I think that should be it. So now we should be able to try to compile this. We have the test.tasm here. So, yeah. So let's see what actually happens. So let's build it and see. All right, so we do get some warnings. So these are not handled in the switch. This is in there. Oh, I did not break in the default. So, what's that? Alright, so I want to get rid of this. Okay, so I forgot semicolons. That is the issue, actually. Okay, and there we go. Build it again, and alright, R3 undeclared. Yeah, so this is actually type. Type. And these are just placeholder names. I might come up with, like, actual names that have meaning, based on what the registers do. So, that is not good. So that is in the parser. 106. R0. There we go. Let me actually add a space there. Whoops. There we go. Yeah, so it looks like it compiles now. So let's see what happens when we try to run this program. Alright, expected non-type but found label. Okay, so 1, 2, 3, 4, 5. Okay. So it doesn't like that. So the move did not get set up properly. So let's actually go into the Lexer, and let's print all the tokens and see what we get. Have to build it again. Okay, so we have move, and we have a label. Oh yeah, because we don't include numbers in there. It should just be anyone but the first one can be a number. So that should be fine. If we go into the Lexer, in the so basically it's generate. Let's see. We check is alpha, then generate keyword. So generate keyword in here. Is name. All right. Keyword name. All right. Well, let me see. So this is name. So or current is digit. is digit current index. Okay. Because just the first one can't be a digit. Yeah, so that should be fine. So let's build that. Let's run this. Okay, so now still didn't work. Expected non-type but found int. So that is with this one. So it doesn't like this. Expected non-type but found int. Okay. So text is R0 int. Yeah, so that should be fine. So it doesn't like that. So in the parser, non-type. Where do we say that? In syntax there. Okay. So this is generate list. So what is that? Okay, so how does this... Alright, in here... Let's see, where else do we say non-type? Is that it? Okay, so that is where it is happening. Ooh. Yeah, well, we should iterate through that, so I must have not iterated properly. So we do index plus plus, then we do index plus plus again. So that should be fine. Current token equals that. And then, yeah, so index plus plus. So that, why does this not work? Do I have to call index plus plus again? I don't see why I would need to. Alright, let me go back. That's gonna break it though, right? Whoops. Sarcasm. Okay, yeah, so it doesn't like that. Perhaps I need to move this up more towards the top. Let me just put it up here and see if that does something. So let's put it right here, actually. Right there. I mean, I don't think that'll fix it, but we can try it. So, yeah, so it still doesn't like that. So why does it do this? Because this is a type move. So is the type move not right? Well, let's just printf move, and let's see if we actually make it into here. Ooh, okay, that's actually kind of hard to tell. So let me add some gibberish in there. Bum, bum, bum. Okay, so it doesn't seem to work. So did I place the move in the wrong spot? Move. So we have move here, so it's right after move stir, but it's supposed to come before move stir. Yeah, I think that is the issue. Okay. There we go. So this will just be moved. There we go. And now, okay. Still didn't work, but we did actually get the type move. So that fixed part of it. Ooh, the issue now is that we iterate one too many. No. So I must have gotten rid of that. So what is the issue? Expected non-type but found int. So we only have 3 tokens here, and we should be iterating through all of them. So let's printf pretty token current token, something like that. Is that, do we have a current token? Is that what it is? Yeah, we do have current token. So alright, so do we so let's print it right. Whoops, no, I moved the wrong thing. Yeah, right here. Actually, I messed up that printf really bad. So let's do %s like that. There we go. Alright, now let's run that. Move. Okay. Alright, let me print it there, and then we should get a lot of span. So that's not good. Okay, so printf. Let's see. Let's look at the pretty token. Yeah, so that returns a string. 1, 2, 3. There we go. Build that. Yeah, so I don't see why this would not be printing. Alright, yeah, I don't know what's happening in here. This is... Oh, okay, well there. So I printed it there. Yeah, so it's left on that one. But that should be up here. Oh, you know what? Yeah. Okay. I think I know what the issue is. So we moved this up, and that was actually a big mistake because we end up on that token afterwards. So it does need to go down here. So that is quite important. So I'll actually add it right here. And then it should iterate. Yeah, it'll iterate at the end of the iteration. So let's build it now and run that. Okay. Oh, I forgot to actually add it in here. We need to add all the instructions that we have. So, yes, we have inst move, which goes right here. Inst move, and then yes, we shouldn't need that. So let's build that and run. Okay, if I can run it, that's not 1,000. Okay, so that didn't work. Is it trying to get? Let's see. Equals. Where do I put? Where did I put the? Ooh, okay. This needs to be type move, not to change that. It would appear, and then we don't need any of this because it's just for move, because that's the only one that we can work with registers, at least right now. Okay, there we go. I think we finally got it working. So let's try to run this, and it should fail. All right, perfect. Okay, so I think it is working now. So now we have to add support for the instruction, the move instruction. So basically, what we want to do is we have the index, so we just need to set the register index equal to the value. So it's in move. So basically, the value is going to be whatever is there. So the value, yeah. So this is the value. So we need that. So I think we can do machine registers, and then machine instructions IP dot let's see, dot what did I call it? Register index. Yeah, so actually there we go. Equals machine instructions IP dot value. Alright, yeah, so we can just set it equal to that. So I think that's basically all we have to do. We do have to break though. Break like that. Build it, and we have a problem. Type register. Okay, yeah, so we need to do dot value. Or what did I call it? Where do we define the register? Let's see. It's down here actually. Register, yeah, dot data. So the data of the register is being set to that. So let's build that. And now let's try to run it. So test.tim. And it did run, but we don't really have a way of testing anything out. So I'm thinking, so should the move be able to move it to the top of the stack? Or should we use push for that? Should push be what moves it to the top of the stack? I am not sure. Let's print the value of the register. So print f. So yeah, we'll just print it as an int, since that's what we're using. And then we'll do machine registers, and we'll basically just copy what we have up here. IP dot register index dot data. Yeah, so let's just print that and see what it is. Oh yeah, dot data dot as int. There we go. Build that, and now let's run this. And 1, 2, 3. Okay, so it looks like it did work, and it set the register value. So yeah, we do need a way to get this onto the stack, because right now none of our operations support anything to do with registers. They only support the stack, and I think it's probably better to keep it that way. And the registers are just used for moving stuff from the stack into the registers, so then you know where they're at, essentially, and then you can move them back and forth from the stack. I think that is the way I'm going to go about doing it. So, let's see. So if we do push, and then we type a register, then we'll just push the value of the register. And it'll leave the value in the register, but it will push it to the stack. I think that is the way to go about this. So I think we just need to implement that in the parser. So we just need to essentially, in the parser actually, let's see, where do we do this? So we have, this is check labels. We want the actual parsing. So let me search for type move. So this is, yes, this is where we're checking to make sure it's a register. So we can check to if it's a register as well. Yeah, so let me make a new function for check register. So here we have expect token, but do we have another one for check something? It doesn't look like. Let's do int check register. So basically we're just checking to see if it is a register. So we will just take the current token, right? Yep. So token, current token. And then, yeah, we just basically do what we're doing down here. We can just copy this exactly, paste it in there. And actually, that is 2 lines, so I can't just do that. So right here, yep. So I'll just link all of this. And then place it up here, check registers. So if actually, yeah, we'll just take the Lexer instead. So Lexer. Then we'll just return 1. Otherwise, we'll return 0. Yeah, so that'll just check. Maybe I'll do check if register, and then we can just call that here instead of typing out all the register names. We can just do check if register, and then we'll just pass the Lexer in here. Yeah. So is the Lexer actually a pointer in here? It might be. Yeah, it is. So we need to. Yeah, we'll actually take it as a pointer here as well. Just that'll make it easier. And then in the push, we can also do and check if register. Not. So not check if register, and we'll pass the Lexer in here as well. Ooh, okay, so now we're getting some problems with this. Doesn't like it. Oh, because I need another. There we go. Yeah, and I will actually move this onto a separate line because it is getting kind of nasty. So I can. There we go. All right. Yeah. So yeah. So that should look good. And then let me move this to a new line as well. But indent it properly. There we go. All right. So now we're checking if it's a register for push. So let me just make the test program. So we'll do that, and then we'll push R0. That's what we want to be able to do. So in here, I think we should make one for this as well, for this switch statement. So I'll just take that. Yeah, and then I'll just make a little function, which returns an int as well. Or it'll return the size t, I guess we could call it. Basically, get register index is what we want to do. And then I'll just paste this in here. We need to just pass the head value. So let me do that, and then I'll this 3. Whoops. Let me do that 2. Okay, yeah, that looks good. So we just need so that is a node. Is that, what do I call it? A parse list. Parse list head like that. Yeah. So here, want to actually return 0, and then return 1, and then return 2, and return 3. So, yes. Okay, so we can do that, and we can get rid of this entirely. Yeah, we'll set it down here. Otherwise, yeah, we'll do that. And we'll just return -1, because it should never reach this point ever, so we can do that. So now, down here, where we had that before, we can just do instruction register index equals get register index. Okay. Bam. Now we have the register index set like this. And now we can do this as well. So we can just add an else if here. Else if head value dot type equals type. Yeah, so actually we should add that check here as well. The same check that we have in the parser. So it is just let's see, how did I call that? So it is check if register. So let me paste that in here. Equals check if register. And I think that will work. Do we have the Lexer in here actually? I'm not so sure we do. So that might be an issue. So we need to really just pass directly what we're checking. So let me modify this a little. So check if register, instead of lexer, we want to just pass the lexer token stack index dot type. So this will just take a token type. Yeah, so we'll just take token type, and then this will just check type. Type's not equal that. And actually, I think this is broken because we're checking if it's not equal to it. But we want to check if it is equal to it. So this will actually, we'll swap these around. There we go. That should be good. And then we can check, let's see, where did I do this? Equals, check if register, and instead of lexer, we will pass the head value dot type. Actually, yeah, so we'll do this, check, there we go. And then we'll set the register index equal to that. So this won't have a value if this is push. So otherwise, we'll set the, right here, by default, we'll do instruction, register index, equals -1. And, well, actually, we can't do that because it's a size t. So, maybe it shouldn't be a size t. Because we need a way to check if it's a register. Well, actually, we can set the data type equal to a register. So we can just add that to the data type. Data type, that is fine up here, and then this is just register type. It's not really a data type, but that way we can actually just set instruction data type equals register type. And now that's not the best way necessarily going about doing that, but let's see what this will do. So we have some issues. Register type not handled in switch. So that is in 10.c290. Yeah, so we have the types here. So case register type, then return the -1, because we do not want that in here. So yeah. Okay, so register type. Alright, and let's see what else we have. So expected token type, but argument is of type lexer. Lexer pointer. Okay, yeah, so I didn't actually change it back here. So down here where we have check if register. Yep, we fixed it there, but we didn't fix it on this other one that we used. So this needs to be current token dot type. I think that's what it is. So build that and then post a declaration of that. So that is in tasm.c. So do we not, because we didn't define it actually in the header file. So let's do that. Tasm poster.h. So that is right here. Yep. Whoops. Let me get that, and then we'll go over here, and this goes right for generate list. Right there, and bam. Alright, and now we should not get that problem, and it works. Okay, so let's try to compile it. Expected a register, but found a register. Okay, so that is not good. So that is on here. No, hold on. Let me run that again. But found R0. So it doesn't recognize that as a register anymore. Wait, hang on. But if we get rid of this, does it? It does not. So, yeah, something broke somehow in here. Register. So, we need to do not. There we go. Yeah, now it should work. So if I go back to here. Okay, so it compiles at least. And now we don't actually handle it in here. In the push, type push. Okay, it's just int push. That's what it is. So we were just pushing it, but we need to first check if it is a register. So if the data type right here, this, whoops, I didn't mean to actually remove that. Blam. Okay, so if it equals type register, then we have to get the value of the register. Else we don't. John Win 10, let's see, 10,001 followed. Thank you, I appreciate that. Okay, so here we're doing that. So otherwise we need to just push the value of the register. But we don't actually have a data type for the register. So that could be a problem. Yeah, ooh. I didn't actually consider that. So we can easily get the register. Because we get the, yeah, so we can just do the same thing that we do essentially in here. This is actually a long thing. I feel like I could shorten this. Yeah, let me not print it out there. Let me yank this, because then we can, basically, we will push sort of this. Not exactly though. So we're not setting it equal to anything. And we were just push machine registers. Yeah, so we'll push that. Dot data. But we also need the data type. So for now, I'll just do type int, so I can test to make sure it works, and then I will actually add that. So too few arguments. Ooh, I need to pass the machine as well. I forgot about that. Here we go. Okay, so this doesn't work. Type int undeclared. int type. Int type. There we go. Build that. Okay, type register. Register type. It's not really a type, so that name's not exactly right. But yeah, so that works. So let's try to actually emulate this now. And we don't actually print anything, so let's just print it. And this will print whatever's at the top of the stack. So, and it should be the value of that register. Okay, and it is. So, we just need to pass the type as well. So I think we can do that pretty easily. In here, when we set this, let's see, type move, we'll do this. So actually we are setting the data type, so it should be pretty easy to set it in here. So when we push it, or when we, yeah, so we need to modify the register. So the register has to also contain the data type. Yeah, so data type, data type. There we go, and then we'll just set the data type super easily in here. So machine, register, yeah, so it's the same thing. So maybe I should make that a variable or something. Instructions. I did that wrong. IP.register index dot data type equals machine instructions IP.data type. And there we go. And I think I messed, maybe not. Let me build that. Okay, so it compiles. So I didn't mess any of that stuff up. So then we can just, instead of this, we'll just pass the data type of this. So instead of data, we put data type. Whoops. Yeah, I just copied that and then got rid of it, or yanked it. So let me skip there and bam. Okay, got data type. There we go. And now we should have the correct data type. Okay. So let me compile it. Test.tasm. And we don't really have a way to check the data type. I could print it out, but I don't feel like that's worth it. So let me separate this so it's not. There we go. Okay, so now we have registers. Let me make sure it works with all the registers. Okay, yeah, so that looks good. And if we do this, then it would just be, yeah, 0. So there's no value there. It's really null value. Yeah, okay. So you can do that with registers. There's no default value to them. But now we have a register, or 4 registers rather, that we can do stuff with. And it'd be pretty easy to add more. I need to clean up a little so it's even easier, but yeah, so registers right now, it's really just for storing data. So like you can move, we need to be able to basically take something from the stack and move it into a register, because there's not really a way to do that right now. So how could we do that? What if we have a keyword which is just like top or something like that, and it will just take the top of the stack? Is that a good idea? Let me think. So is that how I would want to go about that? Let me just remove test.tasm, test.tim. Okay, yeah, and then I'll quit out of this, and then I'm going to push this while I think about that. Or I'll commit the changes. So this is in separate branch, so it's not main. Let me add. Actually, I can modify the to-do list because we did add this, add registers. But now we need to basically make registers usable, because right now they're not really useful. Not usable to any significant extent. So let me add that. Yeah, so added 4 basic registers, and it's quite easy to add more. They're not very useful now. And I messed that up, but I don't care. I'll fix that. do okay, yeah. Okay, there we go. And let me make sure it works. So I'm not gonna pull request now because let me refresh and then I will check out the registers branch and make sure, well, I guess I know it worked because so that's perfect. Yeah, and I'll merge this once they're all implemented, and because I might just completely give up on this, if they're not particularly useful. Because we do have arbitrary access to the stack, so we can access any part of the stack very easily, and we can kind of use the stack as a register. Like the bottom of the stack actually is kind of usable as a register. So we might not need them, but I'm just want to add them, and I think they might be useful, like particularly for strings. I think that would be the most useful use case. Yeah, so right now they aren't very useful because we don't have a way to use them. So test.test. So like I was saying before, move into the register some value. We want the top of the stack. We want a way to get the top of the stack into a register. So I think that's probably the best way to go about doing that, is just saying top, and that would get the top of the stack. Because we can't really use just an index, because that would just be like moving 0 into it. So unless like we surrounded by that, but that would, then we'd have to worry about parsing all that and everything. I think it'd be better to just use a keyword. So top, I think that is fine. So then we just basically set up the stack how we want, move whatever we want to the top, and then we can just move that to a register. So I think I will do that. So in the Elixir, let's add type top. So this could also be useful, like wherever we encounter it, we basically push the value of the top. So if we do push top, that'd be valid as well, and it would just push, like basically duplicate whatever on the stack. So that's maybe not particularly useful. Yeah, maybe not. Yeah, maybe it would just be for this. Unless there's some other use case. I can't really think. Yeah, because we really have Git for that. So maybe there's a better way of doing this. Let's see. I'm just trying to think, what if you just don't have the value and then it just takes the top of the stack by default? Could do that. I don't know. I'm just trying to, I want it to be good, you know? Okay, I guess we'll just do top. We'll do that for now, and subject to change. So type top. We do need that in the .c as well, or .h. So inst top. Yeah. So do we need that? Well, so let me think about how we would actually add that. So in the Elixir, yeah, so it'd be set as a type. I want to open Elixir.c. So it'd be set in here, and then, yes, okay. And then in the parser, we just check whether it's one of those or it is top. And we depend that. And then in Tasm.c, yeah, so we would check, we would get the register index, and let's see, where is that at? So right here, and then type move, and then, yeah, and then we set see if it's type null, and then let's see, yeah, so push pointer. Right, so that's actually not gonna work because we don't want it to be pushed. So this actually fix this. Yes, because that's not gonna work. So we can't move null right now. So I need to figure that out actually. I might not need, I don't know. So I'll figure that out because yeah, null is a little weird. But for now, we won't worry about that. So we can set this here. Okay, so it'd be something like else if head value.type equals type top. And then I need to actually add the closing bracket here. So let's see. Then we would set the value equal to yeah, so it wouldn't be the actual type. So what would it be? Be equal to some enumeration. Oh, but then it could be equal to an int, so that might mess things up. But basically we can set the data type, if we have a data type of type top, or top type, yeah, then we wouldn't actually need the value at all. yeah, we should probably do that. So instruction data type equals top type. Yes, we don't have that actually. So we would need to add that. Yeah, so in here we could just set top type. So these, I should probably move these out of here because they're not really types and it's not really the way it should be used, but yeah, not doing that right now. So got that, and we don't need to set the value at all because the value is taken from this. So that is fine. And then in the Lexer, we will add down here, let's do type top. And then in here as well, we can just add top. Let's see, it goes right after label, right? Yep. So, yeah, just top. And then if wherever we encounter it, we set to that, okay, that's all good. And then in the parser, like I was saying before, yeah, so only for move at the moment at least, or it is, let's do, and Lexer token stack index type does not equal type top, or top of stack. I guess, I suppose. Then we'll just append that, okay, and that should all be working. We just don't have, oops, I needed that. We don't have support for it in here, so we need to go to the move instruction. So we need to check, basically we can do what we did there before. So, machine, yeah, so, yeah, machine instructions IP dot data type equals type top. Then we'll do other stuff. Otherwise, we'll do this. So I can just grab these and throw them in here. There we go. Okay, so if it's the type of top, then we want to set the data in the data type equal to whatever's on the top of the stack. So we do that and data type as well. Whoops, there we go. Okay, and the data type. So then this equals the top of the stack. So equals machine stack size. We have to do -1 because this actually points to one above the stack. -1. Yeah. Dot word, I think is what it is, right? So the top of the stack is made up of data. Yeah, so dot word, and then dot type is the type. So the same thing, but dot type rather than word. So that is pretty easy to do. Dot type. There we go, and there we go. Yeah, so that should work now. So assuming I won't make any big mistakes. Okay, type top. In 10.c, we don't have type top. Oh, it's top type. Yeah, so that is actually not right. So we need to be, type top. What did I call it in here? Yeah, so let's make it type top. Actually, so this need, yeah. Ooh, okay. So this actually interferes with the Lexer. Okay. No. Okay, so I call it type top because that's what it, okay, that's a little confusing. In the Lexer, the token type is type top, but then in here we have the actual data type top. So yeah, so it needs to be top type. There we go. Yes, just like that. Is that how I had it before? It might have been. Yeah, so it needs to be top type. Okay. Yeah, so I named that very confusing. And I should probably fix that. Top type is not handling the switch, so that is okay. That is 290G. Whoops, that is the wrong one. 290G. 290G, there we go. Yeah, so we just need to do the same thing here, because we shouldn't encounter it in here. So, top type, then return, and I could just use default here, but I do like it to learn. So, let's do that. Okay, and let's try to compile this. I actually don't have a way to do it. So let's then push R0. Whoops, that is not R. R0, and then we'll print. Okay, and that should show us what's going on. So I didn't need to rebuild it, but I did anyway. And then we'll do this, and 0. Okay, so it didn't work. Oh, because there's nothing on the stack. So let's push 5. There we go. Okay, so it worked. I'm assuming it worked. So if I get rid of this, then it's gonna be 0. Yep, alright, so it did work. So now we can move the top of the stack. So registers are a lot more useful now. Because we can actually use them. Yeah. So, yeah, we can do move R1 top, and then move R2 top, and we can push 5, and then 6, and then 69. Perfect. Okay. So it would be in this order. So 69, 6, and then 5. And then we can push this back to the stack. Yeah, so then we can push R0 and we can push R2, and then we can add them. So then that would be 69 plus 5. So yeah, that's what it should output. Ooh, okay, and it just did that. So it didn't actually work. That is interesting. Is add broken? Did I break add? So why would it be just that? Oh, you know what? I think I know what's going on here. So, in here, if it's a register, no, we are pushing, so that should be fine. Why are we pushing twice? That is not right. Yeah, so that is actually an issue. So yeah, I actually completely, because we're pushing twice, so we don't want to do that. So let me try that again. 10, 10. Alright, 138. So that's not right. So now we are just pushing once, so that is what we want. Let's see, in here, we move that, -1. We aren't popping it off, though, so that is actually the thing. So we do need to pop. Pop it as we go. 74. Okay, so that is the right value now. That is what I was expecting, but yeah, I forgot that this doesn't actually pop it off, and that is something that I do need to keep in mind. And I think I don't want it to pop off, because sometimes we just want to move it over and then be able to move back. Yeah, so that is fine. That should be fine. So let me make sure it's right. Let's change this to R1, and then I'll make, whoops, and then I'll make this R2, and then 11. Okay, yeah, so that, it's looking right now. So I think that is pretty good. So now the registers, we can get the top value. So I think I will commit this now as well. So if I exit out of there and remove test dot all that, and then yeah, I'll just commit it. So basically made registers actually useful by giving them access to the top of the stack. Here we go. Okay, and then I'll push that. Okay, so now we have registers that we can use. So, yeah, so something that I was thinking, and it did work. Okay, so something I was thinking would be useful. So we can push strings, like that. And then we can get the string. And that will basically put it on the top of the stack. Then we can move R0 top. So that will move the top into R0. And then we have the pointer there. Then I feel like we could use it now. Like, so then we store it there. And the reason that was useful is like when you're reversing strings and such, if we have a way to sort of store the value and know where it is, it's a bit easier to process at least than worrying about the stack constantly. Yeah, so that's sort of what I was thinking, because then we can move the value there, like sort of the one that we're comparing, and then move it back when we need to see what it is or iterate on it or something, and then move it back again, and then pop it off, obviously. So that is kind of what I was thinking the usefulness of them would be. Yeah, so something else I was thinking. So right now we have swap and inswap, and the same thing with dupe. However, the way that they work is the values attached to them are actually the values on the stack. So if you do, actually these don't have it. So swap, it will swap the top two elements of the stack, and dupe will duplicate the top element. But then in swap 0, that would actually take the bottom element of the stack, and I'm not sure that's completely useful, because we take the bottom element and would put it on the top, then we can work with it, but then it's kind of hard to know where it goes back, if that makes any sense. So I was thinking maybe basically the 0 would be stack size minus whatever the thing is. So if it's 0, then we would just take the top element of the stack and swap it. And then we wouldn't actually need two instructions for this, because in swap 0 would be the same as swap. Something like that. But I'm not sure. Like, also, I like being able to access the bottom of the stack easily and knowing where it is. So I kind of need to think about that. So, yeah. Let me see. So we have the registers now. Yeah. So we don't actually store it in here. Okay. So then the registers have the value. So register index. I'm just kind of going through and thinking right now. And then we have, okay, that is the register. So is there anything else that we would want in the registers? Because right now we can store the word, which is defined. I guess we could just make it a data instead. Yeah, because the data is kind of now the same as a register. So I might consider that. Yeah, I don't know. I will think. Yeah, but is there something else that we want? So we have the word, which could be any of these. So this is most of what we need. We have some sort of int. In the future, I will add data types for all the different types of ints, like unsigned integers, 8-bit integers, all that stuff. Same with floats and stuff like that. But right now, this is kind of all that we need to work with. Because the void pointer can be used for all different kinds of types, and it can be like casted to a string, right? So that is pretty useful. Yeah, but is there anything else that we would need? I don't know. Anything else in the registers? I was thinking, so let me just search up register-based virtual machine, and I kind of want to look through an implementation of it. Let's see. Yeah, this, very simple. So, then I can look at how it's implemented by someone else. This one, I believe, I was reading about it. I think it is just register-based. I don't think there's any stack at all. Whereas mine has a stack and registers. Kind of has registers. So let's see if we bn.h. Do we have, let's see, register. So register count, okay. Let's see. So register. So these are the registers. So it's a union, integer or a string, okay. And then the type. All right, so that's all that they have in there. So that's probably fine. This is a rather simple one. Like it, simple VM. Yeah, but I think that's fine. So let's see. So we have registers now. Yeah. So I think what I want to try to do is actually reverse a string. So I think that should be possible. Yeah. So let's push through. So we can push just hello world. Just like that. And this is actually null terminated. Strings by default are null terminated. And then we can get the stir. Actually, we want to duplicate it, perhaps. Yeah. So let me try that. Dupster. Dupster. Let's see, can I just do dupster? I think that I can do that, and that should duplicate just the top of the string stack. Let me see. Is that the name of the instruction? I kind of forget my own instructions. Team.h. Let's see. Yeah. So indupster. We just have indup. Yeah, we have dupster. All right, perfect. So we can duplicate the string. So then we have two of the strings essentially. So we get the first one. 0 would be the bottom of the stack. So that's what we're getting. Then we have a pointer to it. So I can actually kind of show this. So I push 1 and then native 1. That is right syscall. And let me just build it, make sure it's all good. And then let me compile it. And there we go. Hello world. So we have that. And we can also make this third one. And we can get hello world again. So we have two of them on the string stack. So what I wanted to do is modify it. So basically we want to go to the end. So what we can do is actually Sterling. We have that. So that is, I forget what it is. So we have Sterling is native 94. So if we call that native 94, that will get the length of the string on the top of the stack. Yeah, so then I kind of want to add by that amount. And then that should be the end. That's stack underflow, so that can work. Does that consume it? Alright, yes, then we print nothing. So let me add, well, let me push 1 and then sub. Because I don't want it. Yeah, okay, so I forget how to do it exactly. Let me push 1 and add just to the string. Let me try that. Yeah, okay, so we can do that. So the Sterling, let me actually print the Sterling. So let's do Sterling, and then let me just print, and that just prints as any data type. So that didn't work because it's native 94. So, whoops. Now it's running. Okay, 14. So, yeah, if we add 14 to that, it would be all the way at there. So it includes the null termination. So we need to subtract 2, I think. Yeah, so let's push 2, and then sub, and then add. Actually sub, and then that should be 12, right? So maybe actually, let's do 3, and let's see what that does. And then we'll add stack underflow. Okay, so, because I didn't do it again. And then we'll add. There we go. Okay. Yeah, and so then we'll call the write system. So I'll push 1, and then native 1. So let's try that out. There we go. So that is the end of the string. So that's the last character. Really the new line. Let me just get rid of the new line, because that makes it kind of confusing. So then we can just, sub 2. Well, we shouldn't need to even do that many. I think it's broken. Okay. I'm not sure what happened. So it's going one too far now. So, I don't know what happened now. What if we just push hello? So, let's do that. Alright, yeah, so let's do push 1 inside. Yeah, so 2, and that should be pointing... Okay, so I'll need to look into what that problem was. But there, now we do that. So that puts us right there. And that's what we want. So now, now if we do get stir1, then it should be pointing to the start of this second one. So if we do that, hello, alright, yeah. So we basically want to set the first index of this one, and we can actually do that by doing index, something like that. And then let me actually get stir1 index, and then we'll print it. And actually it broke. I think I'm using index. Let me see. Let's see, index. So, yes, we do actually need to push the index that we want to modify. So, if we actually push that here, so push 0. Might go, okay, yeah, 1 LO. So, we want to set it to the character value of, yeah, so actually, if we do DREF, yeah, this should maybe be on the stack, actually, rather than an argument. And then I think it would be a lot more powerful if we can access the stack. So, yeah. Let me try that. So, basically, modifying the code to make it look better is what I'm doing. So, in the parser, we want it to not... And I'm not using any examples in this because I just implemented this recently, so it shouldn't break anything. Or at least not too much. Yeah, so type index. So we want it to just be on its own. So let's just completely remove it from there. And then in the Kazoo.c, we want to also change it here. So yeah, we just want that. So yes, that should be fine. Then it's gonna completely change how this works in the actual implementation. So the index, so I feel like we should push the index and then the actual value. So let's do word value equals pop machine dot word. Alright, and maybe it will actually be a data value rather than a word. Because then we have the type as well. Okay, index is less than 0. So yes, this is the index. So that is fine. So then array. So this is what we are actually changing. So yeah, that'll be the lastmost thing, and that is fine. So then this, yeah, so right now we set it as a character, so we can do that for this as well. Because that's sort of all that we want to do. So let's do value word as character. And I think that should work. Now it should work with just popping off the stack. Assuming I didn't completely break everything. Yeah, actually, so we don't want that there. And then we can push 1. And that should basically work the same way. test.tim, we'll call that, and okay, perfect. But now we can actually, so let me, after we get to the end of the string, so this is the end of the string, then we will basically move R0 top, and that'll be the top, which will be the pointer to the end of the first string. So that will be in R0. So then we'll be able to access it. This is kind of what I was talking about. Yeah, and then instead of this, we will do push R0 and then dereference it. So then that should make it a character. And no, it broke. So did it break on the deref actually? Yeah, so then that yeah, so I need a way to get the actual get it as a character rather than the pointer to a character, because I can dereference it, but I don't think that works how I want it to work. Ooh, okay. So yeah, we can print it, and it's O. Okay, so why does that not work for this? Does deref... Ooh, deref might actually... I might want to swap and pop. Okay, there we go. So now we get the N, and we're setting it. So this is kind of what we need, and we just need a loop of this, essentially. So, yeah. Alright, that actually did work. So yeah, the deref, it doesn't pop it off when we dereference it. Yeah. So then we want to add one or subtract one from this actually. No, do we want to add? Yeah, we do want to we want to sub. Because then we'll get this character. And then we want to add to this one to set the next character. And then at the end, we want to basically put them each back how they were. So let's not print it for now. So this can actually just be print. Actually, this is right. That's just what I'll call it. So here is where we push the string. Then we duplicate it. Okay, that's all good. So then we get the string 0. So we don't want to do this again, because this is putting it at the end. And we move it to the top, so it's still there. And since we, so we push that, and then it is still there, so we actually want to push it back again, and then actually move it. So this is where we change everything. So let me do that. So what is this push 0 for? That is actually the index. Okay, so push the index. Okay. So that can go up here as well. So this is where sort of the loop will happen. We didn't need to change it. So let's actually push R0, and then we will push 1 and add sub, actually, to make it go back to L. So then that should put it back to there. And then on the next one, so then we'll actually just move R0 top. So we're replacing the value on R0 with the new pointer to this character. Is kind of what we want to do there. And then we have it back on top. So that is good. And then the next one we need to do is we need to iterate the index by 1. So we can do that. So here's where we push 0. And then when we call index, yes, we just want to actually add 1 to that on each iteration of the loop. So what we can do is push 1 and then add. Really, we need an operation to increment. That would be quite useful. Like just kind of inker, something like that. Or maybe just ink. And then de-ink as well. Or dink. Dink, yeah, we can have the dink operation. But I'm not going to worry about that now. So we can push 1 and add. So we'll just start this at -1. And then it will just add 1. So that's fine for now. So that will increment the index. Okay. And then I think that should be fine. So then let's then let me actually, we should save the string length into a register as well. So here we actually call the string length. Let's see. So here is where we do it. So let me move R1 top. So that is where the string length will be stored. Okay, so sub add, and that is actually we want to add. Whoops, we want to add this one. So then we want to get R0, So yeah, just or push R1 rather. So this should be R1. Okay. Yeah. So now we're actually bum bum R0. Why did I move this down here? I need this up here as well. Because it does need to be there. So that's right here. I don't know how I got rid of that, but there we go. So we need it there. So this actually, whoops, let me do that and put this here. This needs to happen immediately following this. And then, yeah, we'll push R1. So this is the string length. And then we'll compare. So let's actually, so we push 1 and then add. So in the top of the stack is just, it's going to be that. And then we push R0, so that's at the top. Dereference it, so that is what's at the top. Yeah, okay. And then we swap it and we pop off that 1. So we have index, then the character that we dereferenced, and that at the top. And that actually all gets consumed. That gets consumed by this. So we should be good. If we might need to pop this off actually. Sub, yeah, and then we want to pop it off. And then we want to push R1. And then we want to compare equal, essentially, is what we want to do. And then if it's equal, we want to, so 0 jump, loop. Otherwise, we want to continue here. So that should put us back in the loop if it is not equal, which is what we want. So, I think that should be good. 0 jump loop. Otherwise, yeah, we'll just jump to right. So, that might not be great. So, actually, where do we have this one? So this, does it get messed up? No, I think it should be fine. So let's actually try that, and we do increment it, so we have to run that. Okay, and it gets stuck in an infinite loop, so that's not exactly what we want. Let's actually print this and see what it says. So 0, actually, we could have guessed that, I suppose. So push R1. So let me see, what's at the top after we pop it? This is gonna break everything, but so the top is the character pointer. Okay. So, ooh, you know what? This gets consumed. So we need to duplicate it. Yeah, let's duplicate that. Then, right, it still breaks. So yeah, actually, if we do this, what is at the top when we print there? So we never even actually get there. So that's not good. Yeah. Okay. I really need a way to debug this, like a debugger kind of thing. Alright, but let's see. So, whoops. So here, we push the string and we duplicate it. Alright, so this is the stack. The start of the stack, we have just the stir. Alright, stir. And then we duplicate it. So we have 2 of them. Stir and stir. And then we call this, which actually, does that consume it? So, this is... Alright, let me look at the implementation of it actually. Because we can do that. So stir len. We have native stir len. So we do pop it off. Yeah, so it does consume that. So that's why we duplicated it, I suppose. We push 2 and then sub. Then do we need to... Yeah, so then that should work fine. So then that is there. So do we need to pop that off though? We move that to the top and then add. So, then, okay, so this is the string length that we're adding, putting on the top, in the R1 register. And then, yeah, so this is that. So these don't actually remove it though, do they? So, do we need to pop it off here? And then we get string 1. So that is the one that we're trying to reverse, which is just hello right now. We push -1, that's where we start. So we push 1, and we add. So then this becomes, let's see, so when we have stir 2 on the stack, as well as 0. Okay. And that should be it. But found string. Yeah, because that doesn't matter. Okay, so... So let me, print, and then print a couple of times, and see what we've got. So that is the native one, and that is the character, and then we shouldn't be able to print again. Yeah, okay, so it's stack underflows when we do that. So those are the only two things that we have on the stack. That is correct. Okay, so we have string 2 and 0 at the top. Then we duplicate it, so we have stir 2 and then 0, 0. And then we push R0. So that is putting, yep, so we have stir 2, 0, 0, and then we have the end of the string. So it's just O, really. Which, yeah, so stir 2, and then at the end of this, it just becomes the character of O, rather than a string. Or a char star, if you will. So swap. Yeah, so we swap it and we pop off this one. Yes. And then we index. So that should consume this one and this one. So then we have the 0 at the top still. So that is actually what we should print here. But it doesn't seem to do that. So I seem to have broken something else. So why is this all broken? Let me just get rid of that. Yeah, so it is broken. So that should be fine. So why is it broken? Index. So where does it break actually? Did we get to here? So we print that, and then it prints the character. Okay, so that's fine. But then we swap and pop. Actually, before we pop, then it should be the string. Yep, okay. And then we pop that off. And then we have the index. We call the index, and it is broken then. So that is quite interesting. So why does it become broken? So we have, ooh. That is not good. So after we pop it off, print and print. Okay. So we have O and then 0 on the stack. Okay. At this point we have O and 0, which is what we want when we call index. So am I actually getting it in the right order? That's actually in here. So let's look at index. So the value should be on top and then the index. Yeah, so that should be fine. But do we have the string? Yeah, so we do have the, oh, ooh, so we have 2 zeros. That is the issue. Okay, so we want, when we duplicate it, we want to actually swap. Yeah, so we can just do int 0. And there we go. All right, so now we have it in almost the right order. So this is not quite right because we have O and then we have the character, the pointer to the char star, and then we have the 0. So we don't want that. So yeah, because we actually want to do this before we duplicate it. Well no, we don't want to. So we want to do int swap 0 and then swap actually. And there we go. So now it is in the right order. We have just the right amount of things on there. So yeah, we call that. Give it a print, and all right, so it still breaks. But now that consumes almost everything that we had on the stack. So it goes down to this point. So actually we have, right now we have this. It's like that. So it should just be left with a 0 on the stack. Then we push R0, which is actually the O, and then we push 1 and sub. So we're pointing at L. So I think we can deref and then print, and it should say L at this point. Yep, L. So that is what we want. That is all working properly. Then we move this. Ooh. Oh yeah, so we're just moving this. All right, so that's fine. We don't want to deref that. And then we pop that off because we don't want that on the stack anymore. So if we print this, then it should just be the 0 on the stack. And it is not. So, okay. Why is that? Because we're left with just 0 here. You know what? We do need the string as well. At the end of everything. We will need the string there. So I'll need to do something about that. But yeah, so we have the 0. Well, you know what? I can get the string at the beginning of this. Maybe not at the beginning, but yeah, we could get the string in here because it doesn't matter because we're just indexing it. So that is probably why we are actually getting messed up. So what I can do is we can push stir, push stir 1, or get stir rather, get stir 1 right here, rather than doing it here. Let me just comment this out. Actually, let me do something. So I can set this equal to assembly, and then there's some highlighting. So I need to make a custom one for this language specifically, but this, I think this works fine for now. Because it makes it a bit more clear, well, a bit more clear where things are, like with the strings and everything. So yeah, I will keep it like that. So, yeah. So we get the string there. And then we have this on the stack. So we have stir to, so what we want to do is, so we don't want to swap, well, what we should do, so we get that, and that is on the top. So we have stir 2 here, and we don't actually have it there. So yeah, we have 0 on the stack, and then 0, 0, and then we have stir 2 at this point. So we need to swap it. We need to swap it. So swap then. Yeah, I think if we just swap at this point, then it should be fine. Alright, so yeah. So now we did something. We printed the same thing over. Alright, so let's see where we're at now. So at this point, then we have the 0 on the stack. But we need to, yeah, so we have the 0 on the stack, and that should be it. So that should be fine. Just the 0, and then we push that, so we have the pointer to this, and it becomes L, so that's all good. And then we move this to the top, and pop it off, but then it's still there after we pop it off. So why is that? Then there's 0, so that is a bit closer to what we need. I don't know why there's 2 of them at that point. Yeah, I don't know why that would be. We stack overflow, so that's still not what we want. But then we push R1, so that is the string length, and then we compare. So we have 0, and then the string length, which I think is 12. If I am not mistaken, I can check. 4. So that, oh yeah, it was 12 before, but now it's 4. So, well, it's actually not 4, but yeah, it's because the null termination character and all that stuff, so that is all good. Yeah, so we compare equal, and then if it pushes 0, then we jump to loop. Otherwise, we go down here. So then it gets stuck in an infinite loop, so it's not iterating properly. So, let me see what I can do about that. Let me dupe and then print. And this will just print it over and over again. So, okay, so we can, if we go up here, okay, so this actually did a lot of stuff. Let's see, can we find the start? Okay. If we go down to where this was at, so we have a lot of stuff here. So we don't have the start, so it doesn't want to work. Interesting, okay. Yeah, it looks like there is no proper start. Alright, let's look here. Alright, so that is there, and then it doesn't stop. So, are we not iterating? We're not iterating it properly. It should be just iterating here. Do we need to actually remove? Ooh, we do have to pop from the stack here. I think is, ooh, okay. I think that's what the issue is, because compare, it leaves it at the top of the stack. So, can we just swap and pop? And that should get rid of it. Okay, so this is a lot closer, because it did stop, but then it seg faulted. But, we do have the string in reverse. And then, I think it broke on the right, because we don't actually have this. We want to get stir 1. Okay. It worked. It actually worked. Okay. Okay. So, this should work if we have anything. So, we can put hello world, not word, world, and that should still work. Okay, it did not. Ooh, that's interesting. So, yeah, that is quite strange. So, is it something with the spaces that throws it off? It is something, because it goes out of bounds. That is not good. If we do this, it will just end there, actually. And it, yeah, okay. So what point does it stop working? So, let me test that. So that works. Oh. Oh, wait, oh. So that does not work. But we do actually get this, so. Okay, yeah, this is quite interesting. So it doesn't work. It's reading past where it's supposed to be. But ignoring that for right this second, this does work. You can put hello with a W and that works. So that, dang, it almost works. It almost worked. Well, just jump to the right, and then, yeah, so we can write the word. So let's, write it and then get stir 0, and then write that as well. And then I will figure out why it is reading out of bounds. So yeah, we can, and then let's actually push a new line here. And then we can derect, and then we can push 1 and native 1, and that should print a new line in between them. It actually broke, so I seem to have messed something up. I'm not sure what it is though. So it doesn't like this. Let me try this and then get stir 2. Does that work? Okay, this needs to be push stir. Okay, so that works. Yeah, so there's something wrong with that as well. So there is quite a few problems right now, but then I'll print a new line at the end as well. We don't need to push the stir again though, so. Okay, so there we go. And now, hello. Yeah, so there is some weird stuff. Does it actually get messed up? Let me try to write it here. So let's see, when we just get the stir, let's just jump to right. And let's see what happens. And it doesn't do anything, so, or it does this, so why is that? Ooh, we got coffee, Java. Oh my gosh, Java is infecting my virtual machine. Holy moly. Okay, yeah, so why is it not jumping? Because it should be jumping right to right. And then, yeah. So I don't know, what if I make another one, end, and that just holds. And then we jump to end, and it shouldn't do anything. Okay, it does that. Then we jump to right. Oh yeah, because it tries to get both the strings, but yeah, so I'm not sure why it's reading out of bounds. Well, let me do this, and let me push 1, native 1, and here we'll just jump to halt. And I need to actually, yeah, it's called end, because halt is actually not a valid label. Okay, so it works here. So, well, yeah, so this we're trying to print stuff here. But get stir 1 should still exist because we dupe the stir. So that should be fine. So let me actually look at what this is. So if I print, let me get rid of this jump and all that stuff. So if I print what this is, then we can see the length. So it's 5. 1, 2, 3, 4, 5. That should be okay. Yeah, and then we stack underscore now. So I do that, and I can see it. Yeah, so, oh, that is weird effect. But yeah, you can see it's clearly reading out of bounds. So I need to figure out if that's a problem with my code here or the virtual machine. Yeah. Let's add a label up here, so start with that. Just so that, just so I remember that. So, okay, so here, the length is 5. 5. Hello. Okay, so why is it like that? Let's do that. And then it is 3. Yeah, so this is a little bit messed up. Let me comment, let's see, we can leave the new line. Let me just comment this out. And this as well. So, wait, why are we doing that? Yeah, that is actually, okay, so that's fine. Let's do that. Okay, so, test. That's what we will use. So it seems to not work at all anymore. I'm not sure why. Actually, we want to do this, so let's do this right here. And then, yeah, so the value is 2. So that is a weird value. Let me implement this. Okay, so yeah, then it becomes 1, and that's all messed up. T set. Alright, so that is actually right. But there is one extra thingy there. Yeah. So it's like almost there. Ooh, now there's a bunch of stuff. So that is a, that's the right value, but then it prints extra stuff. So is that something that I have here? No. Yeah, so 3, and that's still kind of, well, because that's 0, 1, 2, 3, I suppose. Yeah, that's fine, because we're starting at that. So do we want to actually, for less, okay. Well, let me, print what this outputs. So it should be, yeah, 0 on the first iteration. And then let's see how many times it actually goes through. So we print 1, 2, 3, 4. And then, okay, so we want, okay. Yes. Alright, so it's just 1 extra, and I'm not quite sure why. So 1, 2, 3, 4. So that's 4. That's how long it is. You can see all the characters here because we actually printed. But then when we, oh, you know what? We don't set the null termination character. Ooh, okay, I completely forgot about that. So I think we can do that. Or basically, here, if we push R1, and then we push that, and then we index, get stir 0, 1, get stir 1, we do that. Okay, that's almost right. So we need R1 plus 1. So let's push 1 and add, I guess. Implement it. Okay, but now there's that. Yeah, because I completely forgot about setting the null termination character. And that is something that we need to do. So what in the world am I looking at? Okay. Not sure what that is, but alright. Alright, yeah. Okay. So that's right. Then it reads out. So, yeah. So if we don't do this though, then it's not quite enough because we just overwrite it. So let me put 1. And then, yeah, so t set 1. So we need to do the plus 1. Yeah, so that is where we want to put it, but it still reads the extra. So is that printing from something else? Here we get stir 2. Push 1, -1. So if we don't print that, then, okay, we read 1 byte. Ooh, okay. So the first one is being set incorrectly. So let me actually, and I can see that here. That's not quite right. So somewhere up here got messed up now. So if we push 1 dupe, 0. Because this needs to actually be 2. Like it was before, I think. Okay. Still not right. So 3. Then we get cut off, right? No. Ooh, so why is it 3? So why do we have to change it by 3? I don't know. Because there should just be 1 extra. So we should need to do 2, I think, because we have the 1 and then we have to go here. But for some reason it's 3. Yeah, so I don't know. But that looks like it works now. So now can we print the string? can we print the string? No, and I think the reason it was doing that is because we actually go too far on the string when we sub it. Because we actually sub one too far. So we want to do this after, we really want to do it after the check. So, I think, yeah, so I think what we can do is actually put it up here. Alright, yeah. So, let me grab this, and then move it up to here. And then we don't need to actually do that here. Well, actually, I guess we don't do it there, do we? Yeah, so then we can let this be like that. Okay, and that breaks it, actually. So that's not what we want. Alright, yeah, so maybe that's not quite right. So R0 should be what's there. So let's actually do this. Do we need to pop it though, actually? Ooh, yeah, so actually we need to do this. This right here. Yeah, so pop, pop, pop. Yeah, so I think we need to just do something like that. Alright, so almost there. So we have 3 on the top at this point, which is not what we want. So let's print the top right here. Let's see what we've got. So, we've got 3 on the top. So, ooh, what is that about? Where does the 3 come from? Let me print and then print again. Let's see what else is on here. So let me get a stack underflow. So we only have 3 on the top. Okay, so we get to this bit. So why is there 3? We got too many times here, actually. Okay. Text. That almost worked. But that is the wrong one. Alright, then we still... Yeah, so let me move this back where it was. We have to pop twice there for some reason. And we get that properly. But then the next one, it is being pushed too far. So when we try to write it, it doesn't work. So I will... Let's see. I'll write that. Yeah. And that'll be actually... So it prints that one. And it's 1 too far. So I guess at the end we could just add to it. We'll just get, well, yeah, here we can just do that right here, actually. Push 1, and add, and then do that. And that, yeah, okay. Let's add 2. How far are we messed up? But this is kind of not a good solution. Yeah, and then, do we not have no, the null termination should still be there. So, I'm not sure what that is about. Alright, well this is not a good solution to it. So we need to modify this. So, when we go through it, here's the loop. At the end, we do this and we subtract from it. So we do that as many times as the length is. So, but then we should, I think we do it one too many, right? So, here we want to, to move R0, or push R0, and then push 1, add, and then move R0 to top. Alright, let's do that. Let me print the new line. There we go. Alright, just like that. Okay, and then string stack out of bounds. So that actually messed some stuff up. Because we don't ever actually push the new line string. So I'll just push it up here. After we dupe the stir. So then we'll push stir new line. You know what? That breaks stuff, doesn't it? Ooh, I don't think the dupe stir accounts for that. Oh dear. You know what? I think that breaks some stuff. Okay. Test. Yep. All right. Yeah. I didn't even consider that. Oh, okay. So are those instructions are broken? Yeah. Mm-hmm. So, all right. Well, so now that works. But yeah, we do need to fix the dupe stir because basically, what is happening is, I could maybe draw a picture of it. So we have the string stack, right? Oops, that is no good. Let me zoom out a little. All right, we have the string stack. Imagine this is a stack of strings, right? So when we push one on, it gets pushed, uh, basically added to the bytecode. I can show a bytecode here. Let me do something like that, and then we can look at the test.tin file. Sorry, like that. And we can see here at the start, it's actually, okay, this is a rather large file. Alright, yeah, at the start we have all the strings, and then we have data end, which indicates the end of the string. And we can see this is the order that we have it. So we have test, and then null termination, and then test again, because that's what we're pushing here. And then we also have the new line, which you can't really see. That is basically what we have there. So we have those added here. But when we try to duplicate one, that happens basically during runtime, right? And if you duplicate it and then you try to push another one, so we'll have /n here. So I don't have a thing, so I'm just drawing with my mouse. Yeah. Imagine this is test, right? Test, and then that is the new line. If we push it like this, and then we try to duplicate this, this happens on the virtual machine during runtime, so it doesn't put it in the right place where you would expect it to. It tries to put it, puts it actually right here, and actually it takes this one and puts it right there, so it becomes like that. So that is basically what happens. I hope that made some sense. But basically that is a problem that I'm not quite sure how to fix right now. But we can fix it by just pushing this twice, essentially, and then it's in the right order that we would want it to be. So then it works. Works as expected. So let me print the new line here. So yeah, as you can see, there are quite a few problems. But yeah, so this allows us to reverse the string. So let me try another one. Test again. So let's see if that works. Which it might not. Ooh, okay, that was almost bad. Yeah, but you can see it works. So we can try something completely different. Hello world, and we'll add a new line there as well. So then it's gonna print a double new line, but hello world, and they have to be the same. Yeah, and you can see that works just fine. Yeah, so that works. We have, it's not Sterling, it's stir reverse. Yeah, so that's pretty cool. Besides the things that don't work, it is quite cool. So let me try something else as well. Let me push new line and then derect. So I don't know why this didn't work before, but it should work. Let me actually look in here. So we have derect. Yeah, so it was working. I did use it somewhere else though. So at one point that was working. I guess it makes sense that it doesn't work because there's no null termination character. But yeah. So that is kind of, actually I want to reference it. Okay, then it works. Yeah, so that was actually just the wrong operation. Yeah, so then we don't even actually need that. So if I push it here, then it should work all the same for both of those. Hello there, TV Josh. How are you doing? How are you doing? Then we can actually get rid of this and we can dupe stir, and then we don't need this one at all. And then it works. And then we can just modify this one, but we still need to keep in mind, let me actually add that to the to-do. Actually, this is kind of done. But then we have, dupe stir. Actually, it's really probably the whole thing. So, stir operations, don't work, essentially. Yeah, that's basically what it is. Yeah, but now we can modify this to be anything that we want. So, anything or everything. There we go. And there we go. And it reverses it just like that. All here. It's all in my assembly. Compiles to a bytecode. And something else we can do. We can build it for Windows. As long as that works. And then we can run the Wine version of tire.exe. We can run it on the bytecode that we compiled in from the Linux executable. So test.tin, just like that. And it should work. Maybe it didn't work. Okay, that is a little weird. I think my wine is broken. Or something else. Let me see. Yeah, I don't know what this means. I wasn't doing this last time. I tried to do this, so I don't know. I don't know why this is. Yeah, okay. I'm not going to worry about that now. So forget about what I just said. Yeah. I think this test though, we can move test.tasm to stirrev.tasm. And then we can move stirrev.tasm into test. And then I'll move test.tin as well. And then we have it in here. So let me get out of that. And then I will open up open up stirrev. And then I will import standard defs cache. And then I will replace wherever we do the native calls with the actual macro for them that we have defined. So let me just search for native, and then this is right. Pretty sure we only use right for the rest of it. So right, right, and right, and then it should all still work. So if I build it all, and then I go into here, okay, and all right, so it didn't work. 59. Ooh. Yeah, okay. So we can't call that. I'll just call this end, and then I'll just make this the end. Right here, the right. Yeah, so because the macro expands to that, so that doesn't work. There we go, and then we can run this. And it didn't do anything. So oh, because we didn't run the executable. Okay. And there we go. And it works. Okay, so let's make this a funnier thing. So is a screen. I guess that's not very fun. But yeah, just something that yeah. And there we go. And okay. And it just broke. That is nice. Okay, yeah, so there is clearly quite a few problems. Let me get rid of the print though. And then what else are we using? Get rid of that. That was it. Okay, and then it shouldn't be printing. Okay, so we don't need extra new lines if we have them here. So I'll get rid of that. Okay, yeah, you can see there's quite a few problems with it that need to be worked out. And I think most of that is on the level of the actual virtual machine rather than an issue with the code here. Some of it might be bad still, but yeah, I've got quite a few problems in there. But I think this is something that we can commit because it is pretty cool that it works. And now, yeah, we can work with strings a lot better. And the registers helped a lot with keeping track of where things are. So I think it is a good change. I'm not going to merge it to main yet, but yeah, it's pretty good. So let me basically updated to do, but also added a let's see. So it is stirrev as an implementation. All right, and I'll push that. And then yeah, so if you want to see it, it is in the registers branch. There we go. All right, so now I must do something else. So let me get clean. And then let me make sure all the tests still compile. Okay, and then I will just test a few to make sure they work. So fizzbuzz, and that works. Okay, and then fib recursive does work. It's still slow. I need to fix that, but fib iterative is also great. Okay, so all that is working. So now, let's see. So in the to-do list, yeah, we have Windows problems. So I need to Alright, maybe I'll look at the string operations. So, basically, in here, we have stir dupe, dupe, stir, there we go, this is what it is. So you can see here, we pop the machine, and then we push it. So, yeah, so then it's not in the place that you would expect it to be, because it's really not based on order like that. So I think we could make it work as maybe it's not a problem with this. Maybe it's just a problem with how I was looking at it. I like this color scheme. Well, it's just the default color scheme, I think, basically for NeoVim. Well, it's with the tree sitter though. So yeah, I didn't add any particular theme or anything like that, but thank you anyway. Yes. It is quite nice though. I do like it. Yep. All right. Yeah. So basically, I think maybe it was more a way I was thinking about it, because the way it really should be thought about. I don't have test.cas anymore, so let me touch that. I use it as well. Very nice. Okay, so I think it is with how I was thinking about it. So if we push a stir, really we should think about this as being section.data, like in x86, 64, NASM assembly at least. That is how you define it, and then you put your strings in here, like that or whatever, and then string, something like that. That is really what this is, because it just puts it at the beginning. So if I thought about it that way, then I could push the new line, and then I wouldn't expect dupe stir to actually do that, because that is duplicating this one and not this one. But based on the order, it looks like that. So really, all the push stirs should sort of be separated into their own thing, essentially. And this is not valid. So I'm thinking maybe it wasn't a problem with that. It was actually just a problem with the way I was thinking about it. And this is actually a valid way to do it. So then we can just do swap stir, and then dupe stir, and then then how would we get it back to that? So we swap stir. So then this one would be on the top, and this would be on the bottom. Then we duplicate it. So that would put this and then that one on the top. So then we could just swap with the bottom, I think. So in swap stir 0. And that then if we get stir, so then 0 will be the test, 1 will be new line, and then okay, so then it is more as expected. Yeah, so actually then that's not really, well, then I would just want to start it again, I think. So then the new line is on the top. Yeah, because that's how I'd rather have it. So like that. So new line is on the top. So then get stir 1, and then push 1, and then -1, and that should write, if everything worked properly, it should write test. And I did mess something up, because this needs to be push stir. Test.10. Okay, and it broke. So where is that at? Because this needs to be swap stir. There we go. Okay, and it didn't work. So it might actually be broken unless I mess something up. So we swap the strings. So then we just get stir 1 and then push 1 and then -1, and it should be test. Okay, so that works fine. And then if we get 0, it should be new one. Okay, yeah, so that is fine. Then we duplicate it, so it should be test at the top. And then we swap with 0, so then test is on the bottom. New line would be on top, and test would be there. And then we swap them, so new line should be in the middle. And then gets to 1, it should just get a new line. And I suppose it does, but it prints all this extra stuff. Yeah, okay, so I think we break the string when we copy it. Yeah. Ooh. Yeah, because it's reading too far. So I think there is a problem with that. So that is interesting. So when it would have to be a problem with the push stir. So maybe it is actually when we free. Let me get rid of that. Let's see, where else do I do that? Okay, let me free it. Then build it. Okay, no, it still didn't work. Yeah, so it is still reading way out of bounds. So it is probably a problem with our implementation. So I think we can keep that. Yeah, my voice is dying. Okay. Push stir. And so the issue here, so we copy it. It might be with the way we're copying it, I suppose. Uh-huh. So what if we just stir copy? Well, that won't work because is there enough space there? Let me build it. Yeah, so it still doesn't work. No, I want to recompile it. Yeah, so like that. Let me try that. Yeah, so that's still not right. Let me print this. This actually push pointer, not push stir, is what. Yeah, so I'm in the wrong place. I was modifying the right place. So let me print the value that we have here. So when we actually push it, what does it print? Yeah, so it's messed up when we're pushing it. So, so is it when we're, So when we pop the string, does it get messed up? So here, yeah, we return, it's a copy of the string, which is what we want it to be. So we malloc that. Okay, and let me actually, let me print the result here. And let's see if that is, so let me add a label so that I know what this is. And then we can see sort of, result is none. Test ND, yeah, so it gets broken there as well. So test ND. So, but that's when we push it back, right? So there is quite a few issues. Let me add a label to this one as well. And then, yeah, I can just kind of keep track of what those are. So value is none, because that's the new one. Test R. Yeah, so at some point, it just gets messed up. It looks like the first one actually is already messed up. So, what is the length then? Is the length not right? So, so that is where we subtract that. Let me print f what is on the stack. So machine sort stack, machine sort stack. So it's hard to tell if this comes from this point or when we're actually reading it from the file. So this is just on the stack. There we go. Build that, and then we'll run it. And now we have a lot of prints here. So tests, which is not right because it's just supposed to be test, so it is reading too far. So let's look at the first one. On the stack is new line. On the stack is test, and then it becomes test. So yeah, and let's also print let's print the length. I could be using a debugger for this, I suppose. Yeah, and then we can see the length as well. So let's look at the top. So on the stack, result. Test and then 4. So 1, 2, 3, 4. So that should be fine. Are we not setting result I equals that? And then put a semicolon. I forgot to set that. I is undeclared, so that's actually in here. So result length. But it should be, yeah, it should be length actually. So, okay. That is a tag string. So let me, that made it a lot better. But, yeah, then we get this stuff. So, that is not right. Because this is actually the data end, which is signifying the end of the, string area. Yeah, so I don't know. I don't know what that's about. So, because we can see here, it is correct. But then it's not here. Yeah, so for some reason, part of it is reading incorrectly. So let me get rid of these print statements that I added, except for on the stack, because that is, we'll leave that for now. And then I will build this and then run it. And all right, so this is what we actually print in here. So we can sort of see where it's at. So this is when we pop it off on the set, test 4, and then test 4, and test n. So yeah. So it should be data in though. Let me not print it in here, or let me only print it in there actually. Yeah. So that will print. There we go. That will print that. So let me get rid of this one, and then we will only see what we're printing in the file. So that is what we print. So let's look at 0. Let me recompile it actually. And test n. Okay. So yeah, you can see that is obviously not right. So why is that happening? So we're checking the string stack size. So the length is that. And then we push it. Yeah, so it's in here, it gets messed up. For some reason, reads the wrong value. The wrong value. So that's where we decrement that. So we allocate that. That should be fine. And then we return the result. So let's look at actually the pop stir here. And that's just what we call there. So, but then in the let me get rid of one of these. Just that one. Just randomly. And then recompile it all. And see if we can figure out which one is actually completely breaking. Okay. Alright. Yeah, so if we get rid of all of them, then it works perfectly fine. So it is definitely with one of those. So let's try swap. Just swap stir. Like that. And then we should just swap those around. And then, yeah, so it should just put new line there, but it puts all that. So, let's add those print statements back. Right here. So just in the popping part. Because that's where the issue is occurring. So on the stack, then the result is that. Okay. So that should be fine, actually. And then here, value test. Yeah, and then when we print it out, it is not right. Because we're not looking at. Let's print the first one, and then does that one work fine? Okay, what I want to do. Okay. Yeah, so that one is fine. But when we try to print the new line, it is not fine. Okay. Because it's trying to print est. So it's trying to print part of that one. Ooh. I know what it is now. Okay. Nick is there you. I think is how you pronounce that. Just followed. Thank you. I appreciate that. So this is actually where that's occurring. So that is why we're doing the max string size -1. Like that. Yeah, okay. Then it works. At least partially as expected. And then that still works. Alright, so now let's try Bootster. Hello there, Lil Cookie 001. How are you doing? Yeah, so let me do that. Okay, so let me get rid of these print statements now. And I want to test in there and see if I can encounter the bugs again. Because part of it at least is fixed from setting that. So let me build that. Okay, so test, that is fine. So that is what we would expect. And then 2 should be test as well. I didn't need to do that. Okay, and then 0 should be test. Or it should be new line, rather. Okay, new line with nothing. Good, how are you? I am quite well. Alright, so then we'll just inswap with 0. Inswap stir. And that will put, the bottom should be test. Test, okay. And then 1 should be test as well. And then 2 should be the new line. Dang, okay, so then it broke. So the inswap causes some problems. In swap stir. Okay. Index swap stir. So let's look at the implementation here. So we get the length. Ooh, does it have... It has the same value, I think. So we need to do result I and result length equals that. And then, does that actually fix it? Okay, there we go. Yeah, so I think we probably do the same thing in the index dupe as well. Ooh, maybe not. So push that. Alright, maybe... Oh, that is index dupe stir. That's actually what I want to look at. So, push stir. Alright, so maybe that is fine, actually. Okay. So, let me try it. Let me inswap stir 0 again, and then test. Okay, and then 0 should be just a new line. And I don't think I saved that. Okay, and then 1 should be test. Okay, so now let's try the indupe. Indupe 0. So that should be test at this point. So that should put it, I think 3. No, okay. So I think, okay, so that is an issue actually. So indupe, what coding software do you use? Well, if you're asking about the text editor, I'm using NeoVim, which is, yeah, NeoVim is what I have, which I'm using, if that is what you're asking. NeoVim, yes. It's terminal based, so it's not like a graphical user interface. It is just in the terminal. Yeah, so you know what? This needs to be indupe stir. We should have gotten an error for that though. Yeah, that's not good. So it looks like we're not checking the bounds properly in index dupe. Or index is less than 0. Okay, so we check that, but then we push. Alright, yeah. So I need to look at that, but let's see if this works now. So, test. Okay, so that looks like it works. And let's try to dupe 2. And then it should put new line at the top, as well as 1 less than the top. Okay, and then these should all be tested. If this all works properly, then I'm going to say that is probably good. Okay, so I think we fixed the problems with that. So let me look at the index dupe, and then I will actually commit these changes. Yeah, so index dupe. So here, we don't actually check if the stack is empty. So basically, we can just do, yes, we need to actually, if machine stat size less than 0, no, equal to 0, I think, then, yeah, actually, we can do print error, error stack underscore. Something like that. And then if we try to do indupe, it should not work. So let me build this. Found swap stir. Oh, indupe 0. Yeah, so that is where we're doing that. So, run that and we don't get an error. But it's during the runtime actually. So, here we go. Stack underflow. And I forgot the new line. But if we push one, like that, then it should be fine. Okay, yeah. So that is good. That is all good. Do we need to do the same thing for just regular dupe though? No, because we pop, so that's fine. Even though we don't really want to pop, because if we have a pointer to it, then it could cause some problems. So that is, I actually do that in all of them. Like in the swap and everything, we pop it off, and then we push it back on, and it's not, it's a copy of it. It's no longer the same object. So if you have a pointer to it, and then you do swap in the wrong way, it could actually remove that one, and the pointer could be invalid. So that is something that I need to keep in mind. So that is like a to-do thing. So I will actually add that to the to-do. Basically just remove pop from operations, and instead get the top of the stack directly. Okay. Yeah, so I think that this is good enough. We faced a few problems, so I will commit that now. So let me push that. So fix the string operation and a bonus bug in the indupe operation. Yes, gotta love the bonus bugs. Okay, so I will push that. Not a very big change, but it is a big change. Like, Not a lot of code, but a lot of big benefit out of it. And it did my internet die or something? Okay, there we go. So still might be dead. Okay. Then this, okay. And there should be, whenever it loads, there should be a new commit. All right, perfect. So that looks like it worked. So let me do a git clean here. And then I still have the test.tab. I didn't need it. So that's in the commit, but that's okay. So, all right, let's look at what else we can do right now. So, here we've got this. So the strings, now that we have the registers, we can makes it a lot more powerful, I suppose. That's the print error. So let's look in here. And we don't really need this anymore because we can also do this in the virtual machine. We did that even without registers. So the into str, and we can just import that. So that is pretty cool. Get stream, we don't need that. Yeah, so we still do. We rely on C for a lot of things. At some point, once it is like the final iteration, in big quotation marks, because obviously it's not gonna be the final one, but once it's very mature, I want to implement compilation to x86, 64, Linux assembly, like one of those, like NASM or FASM or something like that. Implement that from the bytecode, and then we'd be able to actually, the benefit of that is we could take our assembly, compile it into actual native assembly, and then run it and be, if we do it well enough, it'd be a lot faster than this, because it doesn't have the overhead of the runtime. And then what I was thinking is, even if you just compile to Linux assembly like that, as I was saying, then it will run on a Linux machine. It'll also run, I believe, on like a FreeBSD or whatever that has like a Linux runtime similar to Wine or whatever, but it actually works really well because Linux is open source. And then Windows has Windows subsystem for Linux, so you could actually run that on there. So if you just target that, then it already targets those 3 operating systems. So the only one you're missing, I don't think that Mac OS has one for that. So yeah, I don't think Mac OS has any way to run Linux software. So if you just compile Mac OS assembly and Linux assembly, then you target pretty much every major operating system. And I think that's pretty cool. Yeah. Or you could just do the Linux one and get 3 out of 4. So I'd say that's pretty good still. Even though the main point of this is it's very cross-platform just with the bytecode, because you can run it on any machine. So yeah, but I think compiling to native would still be a good idea. So we don't need this. Yeah, we don't need any of this. Let me see if there's any other printf that I've added that I found out. All right, yeah. So I think we're good. Yeah. So is there something else that I would want to implement right now as a test for our registers? I gotta think about that. So yeah, I'm not sure. Let me look at this this one. So this has just a list of projects to implement in a programming language. I want to see just look at the text ones, because those are the particular ones. So we did reverse a string, and we have FizzBuzz. So that's pretty cool. It's all in our assembly. Yeah. Count the number of individual words in a string. We could do that. Yeah. We do have string compare. So yeah. That could be interesting. Yeah. Alright, actually, it's getting pretty late. I've been streaming for over 2 hours now, so I'm probably gonna end the stream. Yeah, so if anyone has any questions or anything like that, then now is the time to say it. I'll just commit the minor cleanup that we did. Minor cleanup. Yeah, so next stream, I'm going to do more with the registers, and I'll think of some projects beforehand, and then test them out and see if they are useful. Yeah, so if there is nothing else, then I think think we are good to go. So thank you for watching, and I will